Okay, thank you very much for having me. Good morning to all of you. Let me first appreciate the organizers of this program for putting together this program. I think it's apt at this time, and I want to appreciate them so much. And I also want to congratulate you for your presence, knowing that you are going to have a good experience and learn a lot at the end of this program. So I've been handed the topic mobile robotics, and I've added the phrase the future of automation. My name is Martins Oluwaseun Opeyemi from the Department of Mechatronics Engineering, Faculty of Engineering, Federal University of Ekiti. So, what is our agenda for today? Number one is for us to delve into the exciting world of mobile robots or mobile robotics, and also for us to explore what mobile robots are. There are different types, applications, and their impact on various industries. Then finally, we look at what do I need to learn to build my mobot, which is just a short form of your mobile robot. So without wasting time, let's move to the first agenda, which is what is a mobile robot. To the right of our screen here, we see a lot of machine components with wheels, with some frames, and all of that. So these are mobile robots really, and basically they are machines that can move around their environment, which means they move from one point to the other because of the word mobile. And while they move around, they need to do a certain task in the environment. So they are equipped with sensors to detect their environment, to measure physical quantities, basically, and they have actuators by which they have effect on their environment, and they have controllers which helps process what their sensors are sensing and send the right signals to the actuators based on what has been pre-programmed in the controller. Then mobile robots can either be fully autonomous or it can be remotely controlled depending on the level of complexity to which it has been designed. So, what are the types of mobile robots that we have? Now, mobile robots are characterized by the kind of locomotion that is being applied. So we have four basic locomotion for mobile robots. Number one is the wheeled robot, which means you have a mobile robot that the means of locomotion is a wheel. And with that, you have less mechanical complexity. And that is why the wheeled mobile robot is the most common type of mobile robots that you can have. And it has been applied to, for example, the Mars rover, which is a rover that is being sent to Mars to take reconnaissance on the possibility of we humans living out there in Mars. Then also you have several delivery robots, that has been built with the wheeled type of mobile robot. I myself have built one delivery robot using the wheeled typed mobile robot, and there are several ones in the Department of Mechatronics Engineering that has been built for several applications. Then we have the legged robots, which obviously are robots that their means of locomotion is legs, like we have in human beings, in insects, and in other creatures that use legs to move. The benefit of such is that they can move around in uneven environments or uneven terrain with much ease than your wheeled mobile robots would, but they have more mechanical complexity than the wheeled mobile robots. Then also we have aerial vehicle or the flying robot. These are drones. Drone itself is a kind of bee, and bee, like we know, they fly. So flying mobile robots are referred to as drones, and they can be used for inspections. They can be used for reconnaissance, area reconnaissance, or area photography, or even delivery, area delivery as well. Then we have amphibious mobile robots. These are robots that can go underwater like you would have with a submarine. So these are swimming robots. For instance, you have probably fiber cables that go deep down in the sea, and you need to go there for some inspection. you need a mobile robot to go and carry out such inspection for you, or you have pipelines that go underwater, maybe for crude or whatever product that it is, and you need to go and check if there's leakage there, you would be deploying a mobile robot, a swimming mobile robot, or an underwater mobile robot in such environment to carry out such inspection or do some maintenance, depending on the complexity of the design of such mobile robot. So here I just have images of mobile robots. This is an aerial vehicle. Fine is shaped like a bird, but really it's not a bird. It's actually a mobile robot. Then we have this legged one that looks like a spider. It's also a mobile robot, but it has legs for its own locomotion. Also, this one that looks like an insect, and this one with wheels is your wheeled mobile robot. The means of locomotion in this one is the wheel. Now, how mobile robots work? How do they work? If we look to the right of the screen, we can see a mobile robot, which is a mobile robot with an attachment for inspection. It has a manipulator to move around this arm for inspection. There is the electronic box where you have the controller or the electronics of the mobile robot. You have the battery housing, the delivery, the driver motor housing as well, and you have the laser scanner for environment mapping and the analog camera also to practically see its environment. So how they work? They require sensor. They require sensors such as cameras, lidar, sonars to detect their environment and gather information about their environment. Then they have actuators, motors, wheels, arms, etc. to perform actions based on what their sensor presents to the controller. And what the controller does is to process the sensor data and make decisions based on the pre-programmed information in the controller and control the actuators accordingly. So that is how mobile robots work practically. Now for the applications, there are several applications of your mobile robots. Now to the right of our screen, we can see here a robot arm with a mobile robot base for locomotion within the environment. Then we also have a mobile robot platform that bears the pallet where this robot arm will drop these boxes, and this other mobile robot here will take them to a designated location. So for the applications, we have manufacturing, assembly lines, particularly in vehicle assembly lines. If you go to YouTube, you see vehicle assembly are done practically with robot arms and mobile robots. So assembly lines, material handling, welding, particularly in aerospace. A lot of welding in the aerospace industry are done with mobile robots because of their precision. Then logistics, warehouse automation, delivery robots are areas of applications of mobile robots. Then agriculture, seeding, harvesting, monitoring of crops, particularly when it comes to precision agriculture, robotics, mobile robots are deployed extensively in these areas. Then also in healthcare, telepresence robots, surgery assistants. There are some surgeries these days that are carried out with the assistance of robotics because of their precision in such integrated applications. Then search and rescue missions also. Mobile robots are used for search and rescue missions, particularly for navigation of various environments. For instance, maybe an earthquake just happened, or maybe there's a fire, and you want to inspect if you have survivors in such locations. Now, you want to send an human being to such an environment, you can deploy a mobile robot to such an environment to search if there are survivors there. And if there are, depending on the complexity of the mobile robot, it can do a rescue mission as well along the search. So, what are the benefits of mobile robots? The first is it increases efficiency because most of the tasks that has been done are repetitive, and for humans we get fatigue when we carry out repetitive tasks. So mobile robots can do that without fatigue, and you can have your productivity improved. So the first thing is that they increase efficiency and also they enhance safety. Performance of tasks in hazardous environments is risky for human beings, and with the advent of mobile robots, they can do such operations which would minimize the risk to humans in going to such environments. So they enhance safety. They also improve accuracy because they are more precise in integrate tasks so that you can have a more accurate outcome. They are not prone to errors that human being will be prone to when we are fatigued or maybe when our mind is unsettled. So they can give you a more precise movement for delicate tasks and they can minimize your errors. Also, they are good for data collection, particularly when it comes to area photography or area reconnaissance or any reconnaissance of any kind. They are very good for data collection. So they gather valuable data from difficult to reach areas. They are very valuable for data collection. And also they operate 24/7. They don't get fatigued, they don't get tired, they don't go on leave, they don't go on strike. So based on that, they work tirelessly and they reduce downtime in manufacturing or in any operation that I might have deployed them to. Now, what do I need to learn to build my mobots? We have been speaking a lot about mobile robots, mobots. So how do I get to the level which I myself can build one? The first thing for you to know is you have to know the fundamentals, which is mechanics, design, electronics, and circuits. There is no way you can do away with mechanical, electrical, electronics, computer if you would build a mobile robot. That is why you see for mechatronics, they do a lot of mechanical courses, electrical courses, electronic courses, and computer courses, which will make them a complete entity to build machines of this level of complexities. Then you need to learn programming. Most of these controllers, they are compatible with your C programming, either your C++ or your Python. So you need to learn such programming. Then you need to understand programming concepts like variables, loops, and functions. You should be able to create class. You should be able to create functions, loops, control statements in programming. That's why you see mechatronics courses in year 2. They are basically programming courses of C, of Python, MATLAB, and all of that, so that you can have this understanding of functions, loops, variables, and what have you in building complex systems. Then also you must learn robot operating system because that is the platform which is actually created for robots. It makes programming robots easy. It creates that API for you, application interface for you, so that your programming can be done easily. Then you need to choose a platform and develop skills. There are several starter kits or starter platforms like your Arduino pack that you can start with. Get your Arduino. In your Arduino pack, you have a chassis for mobile robot there. You have wheels and all of that, which you can put together to start learning how to build your own mobile robots. Then also microcontroller platforms. Your Arduino is a platform, it's a microcontroller platform. Your ESP32 is another microcontroller platform. Your CPU itself and the Raspberry Pi, they are microcontroller platforms that you need to learn how to work with them. Then you have a lot of online resources that can help you in the development of your own mobots because AI is practically open source. So this helps to have a lot of contributors that helps improve uh, artificial intelligence. So you have a lot of online resources that can help you with your mobile robot development. Then you need to plan your robot. What I mean by that is you need to plan your robots. You need to define the purpose because your mobile robots must be doing something in the environment. It can't just be moving around aimlessly, doing nothing. So you need to define the purpose first. Once you define the purpose, then it will help you to tailor the design and how the mobile robot will be built. Because a mobile robot that has the purpose of welding, the design and the build will be different from a mobile robot that is for delivery. So the purpose will tell you how the design, how the structure, how the mechanical appearance will look like. So it's very important. Then you need to assemble and program. Assemble the hardware when you have already designed and built. Assemble the hardware together. Then you write the code. Then after writing the code, you need to test your code, refine your code, and improve. You need to test for errors and debug these errors, then refine and enhance your code for better performance. So these are the 6 steps you would need to go through for you to say you can build your own mobile robots. So if you have questions that you might want to ask, you can direct them to the NUESA president. He will get them across to me and I will respond to them accordingly, and he would also give you my feedback. So on this note, I want to say thank you for listening, and I want to appreciate the organizers once again. And I want to also tell you to pay attention to all that will be said during this your program. So thank you once again, and bye.